Chronic pancreatitis is persistent, chronic inflammation of the pancreas, often due to repeated bouts of acute pancreatitis. While a history of acute pancreatitis might lead to chronic pancreatitis, these diseases have distinct histopathologies. Acute pancreatitis is inflammation caused by destruction of the pancreas by its own digestive enzymes, a process called autodigestion, and is generally reversible. Chronic pancreatitis is inflammation due to irreversible changes to the pancreatic structure, like fibrosis, atrophy, and calcification. The pancreas is a long, skinny gland the length of a dollar bill and is located in the upper abdomen, or the epigastric region, behind the stomach. It plays endocrine roles. For example, alpha and beta cells make hormones like insulin and glucagon that are secreted into the bloodstream. But it also plays exocrine roles. For example, acinar cells make digestive enzymes that are secreted into the duodenum to help digest food. These pancreatic digestive enzymes break down macromolecules like carbohydrates, lipids, and proteins found in food. But these macromolecules are also found in the cells of the pancreas. To protect the pancreas, the acinar cells manufacture inactive forms of the enzymes called proenzymes, or zymogens. These zymogens are normally activated by proteases, which cleave off a polypeptide chain, which is kind of like pulling the pin out of a grenade. For additional security, the zymogens are kept away from sensitive tissues in storage vesicles called zymogen granules, and are packaged with protease inhibitors that prevent enzymes from doing damage if they become prematurely active. To digest a meal, these zymogens are released into the pancreatic duct and delivered to the small intestine where they're activated by the protease trypsin. Trypsin is a pancreatic digestive enzyme that's produced as the zymogen trypsinogen. Normally, trypsinogen isn't activated until it's cleaved by protease enteropeptidase, which is found in the duodenum. But if trypsinogen and these zymogens become activated too early, then it can cause acute pancreatitis. And this might happen as a result of any injury to the acinar cells, or anything that prevents the normal secretion of the proenzymes into the duodenum. The two leading causes of acute pancreatitis are alcohol abuse and gallstones. With alcohol abuse, it goes like this. Alcohol increases zymogen secretion from acinar cells while decreasing fluid and bicarbonate production from the ductal epithelial cells. As a result, the pancreatic juices become really thick and viscous, potentially forming a plug that can block the duct. A blocked duct is bad news because pancreatic juices start backing up, increasing the pressure and leading to distension of the duct itself. At the cellular level, one consequence of this is that membrane trafficking becomes chaotic. Zymogen granules might fuse with lysosomes, which brings trypsinogen into contact with lysosomal digestive enzymes. Trypsinogen might then be turned into activated trypsin, which begins the cascade of digestive enzyme activation and autodigestion of the pancreas, which is acute pancreatitis. Alcohol also contributes to pancreatitis in other ways, though. For example, stimulating acinar cells to release inflammatory cytokines, which attracts a strong immune reaction. Neutrophils arrive quickly to the scene, and often release superoxide and other proteases, which contribute to the problem. Finally, it's thought that high consumption and subsequent oxidative metabolism of alcohol might produce enough reactive oxygen species to overwhelm cellular defenses and damage the cells. In addition to alcohol abuse, other known causes of acute pancreatitis that frequently turn into chronic pancreatitis include tumors, trauma to the pancreas, and cystic fibrosis. In fact, the term cystic fibrosis refers to the pancreatic cysts and fibrosis that develop in patients with mutations in the CFTR gene. That gene encodes for an ion transporter, and mutations in that transporter cause the pancreatic secretions to become thick and sticky, leading to obstruction of the ducts. Importantly, cystic fibrosis is the main cause of chronic pancreatitis in children. Repeated bouts of acute pancreatitis can progress to chronic pancreatitis. With each bout, there's potential for ductal dilatation and damage to the pancreatic tissue. As part of the subsequent healing process, pancreatic stellate cells lay down fibrotic tissue, which causes narrowing or stenosis of the ducts, as well as acinar cell atrophy. In addition, in certain conditions like alcoholic acute pancreatitis, calcium deposits of various sizes can accumulate on the plugs that form the ducts. This gradual process of healthy pancreatic tissue getting replaced by misshapen ducts, fibrosis, and calcium deposits is chronic pancreatitis. Early diagnosis of chronic pancreatitis is challenging. People with chronic pancreatitis often have continuous or intense intermittent abdominal pain in the epigastric region that sometimes radiates to the back. This pain may or may not be linked to eating meals, and it tends to last for at least several hours. Even though elevated lipase and amylase levels are suggestive of acute pancreatitis, in chronic pancreatitis there may not be enough healthy pancreatic tissue to make those enzymes, so they may or may not be elevated. Oftentimes the diagnosis relies on imaging studies that can identify the structural changes to the pancreas. For example, abdominal X-rays and CT scans might show calcification of the pancreas. The pancreatic ducts themselves can be visualized with endoscopic retrograde cholangiopancreatography, or ERCP, which is a technique where an endoscope is passed down through the mouth to the duodenum, where it's used to deliver contrast medium to the pancreatic ducts. Subsequent fluoroscopy contrast studies can reveal structural changes to the pancreatic ductal system. For example, the duct might take on a chain of lakes pattern due to alternating stenosis and dilation of the ducts. An alternative technique that can also evaluate the pancreatic ductal systems is magnetic resonance cholangiopancreatography, or MRCP. As the acinar cells become impaired, they produce fewer pancreatic digestive enzymes, which results in pancreatic insufficiency. These individuals can have trouble absorbing foods and dietary fats, often lose weight, and even develop a deficiency in vitamins A, D, E, and K, which are fat-soluble vitamins. Without digestive enzymes, fat might pass right through the intestines undigested, leading to greasy and smelly stools, called steatorrhea. A long-term consequence of chronic pancreatitis is the development of diabetes mellitus, which happens as the recurrent inflammation begins to damage the alpha and beta cells of the pancreas. In addition, some individuals develop pancreatic pseudocysts, which in the context of chronic pancreatitis is often the result of ductal obstruction, which increases pressure, induces leakage, and results in accumulation of parapancreatic fluid in fibrous granulation tissue, either within or just outside the pancreas. Not surprisingly, repeated inflammation can also give rise to pancreatic cancer on rare occasions. Treatment of chronic pancreatitis involves controlling pain and trying to control the risk factors, things like drinking less alcohol, eating less meat, and reducing obesity. Individuals with pancreatic insufficiency might require replacement digestive enzymes and nutritional supplements, and those with diabetes might need insulin replacement therapy. Alright, as a quick recap, chronic pancreatitis happens when irreversible changes to the pancreatic structure, like fibrosis, atrophy, and calcification, begin to decrease the functions of the organ. Eventually, this leads to pancreatic insufficiency, which makes it difficult to digest food, as well as the destruction of alpha and beta cells, which makes it difficult to produce hormones like insulin. Thanks for watching. You can help support us by donating on Patreon, subscribing to our channel, or telling your friends about us on social media.